see the video of her and Riley getting at it yesterday during pickleball.
So we're going to just start this so that tomorrow you'll have time to work on the homework in class as well. So the thing with a normal distribution, we can't just list every probability. And because there's continuous data, so we can't even list every possible answer for X. So instead, we need to have some kind of formula or table or something to be able to do that. Now, then it gets tricky because every variable will have a different mean and standard deviation, right? But haven't we done something before where we took different sets of data and we compared them by finding a z-score? Remember doing that? So the z-score was basically a measure of how many standard deviations you are from the mean. And we know a little bit about standard deviations from the mean, even from the empirical rule. We know if it's bell-shaped, you would have a certain amount of data on each side, and it gives us some of those percentages. So if we have normal data, so bell-shaped data, we can turn it all into a similar unit by finding z-scores. So your z-score is your x, your value minus the mean divided by the standard deviation. Then we can use a table to help us find those probabilities. So if you guys look on your formula sheets, so it's like the third piece of paper. It is the standard normal distribution. This has, you notice at the top corner it says z's. So these are giving us z values along the outside. So those bolded numbers are your z's. And then the number inside your table is your probability. So the idea is we can take any normal distribution convert it to z's, and use the probability table. So anytime I ask you to do this, we're finding a probability. Now, because the data is continuous, it is not actually giving us the probability of a certain number. If you look on here, up at the top, it gives you this normal distribution and it shows you here's your z, and then it's got a shaded region. This table is giving you the probability of being less than a particular value. So if my z was 1.0, okay, you would go down, z equals 1.0, second decimal is also 0, so you have 0.8413. That is the probability of being less than one standard deviation above the average. Okay, so this table gives you below. How would you find something greater than? 1 minus the number on the table. We also can see it is symmetric. Like I looked up 1.0. If you look up negative 1.0, you get 0.1587. What happens if you add those together? It equals 1, because the area bigger than 1 would be the same as the area smaller than negative 1. Okay, so it is symmetric on both sides. That's part of being a normal distribution. So I am just going to do one example, and then we're going to stop for today. Okay? IQ scores can be modeled by a normal distribution with a mean of 100, standard deviation of 15. Find the area to the left of a score of 120. All right, so I know it's a normal distribution. So what this is telling me, you have a normal distribution. The mean is 100. I want the probability or the area to the left of 120. So I have to find all of this. But my table that I'm giving is not centered around 100. It's centered around 0. So we have to first find our z-score. So z-scores back from when we did them, that's x minus mu divided by sigma. So my x is the score we're looking at, 120, minus the mean, which is 100, divided by the standard deviation of 15. We always round z's to 2 decimal places. I told you that back when we were finding them before. Not that it was a huge deal, but that's what we typically did. Make sure you round up or down as needed. So what's that give us? 1.33. All right, so now you go to your table. And sometimes people really have struggled with reading this table, so make sure you're with me here. So my 1.3, and then the columns give the second decimal place. So I want the 1.33, and we get 0.9082. So my z was just telling me we are a little over 1 standard deviation above average. Then I can look up that probability from my table and get 0.9082. How would we find area to the right? And that gives us 0.0918. Did everybody find that in the table?